In 1969, the Apollo 10 astronauts heard something unusual on the far side of the moon. Apollo 10 lost contact with the mission control and started receiving a mysterious radio signal. This signal could not be from the Earth because Apollo was on the far side of the moon and no one on the planet could see or contact them. The astronauts heard the spooky sounds for about an hour until they emerged to the side of the moon facing the Earth. However, the astronauts did not report this to the mission control because they were scared and thought they would be grounded on mental health issues. For more than 4 decades, people believed that the mission went according to the plan. There was nothing weird about it. Then finally, the incident came to light when the recorded transcripts were declassified. Now the question that everyone wanted an answer to was, what was there on the moon's far side? Was someone really trying to contact the astronauts? What was the source of the unusual sounds? Before answering all these intriguing questions, let me tell you what's there on the far side of the moon. Ever since we started observing the moon, we've been only looking at its one side. The other lunar hemisphere, also known as the far side or the dark side, is always hidden from our view. When we refer to it as the dark side, it doesn't mean that it isn't exposed to sunlight. The moon has its share of days and nights, just like us here on Earth. This means that both the far and the near side receives an equal amount of sunlight. When we see half of the moon being illuminated by the sun, half of it is on the far side, as it is also being illuminated simultaneously. So when the moon is new, the far side is in full daylight. Instead, when the moon is full, it's nighttime on the other side. All this happens because the moon is tidally locked with the Earth. As a result, the moon rotates on its axis roughly once every 27 days. And this is the same amount of time it takes to orbit the Earth, leaving one side of the moon always facing away from us. The far side is quite different from what we actually find on the near one. Typically, you would encounter a much rougher surface with deeper craters. Besides this, the far side hosts much less Maria, the large and dark patches that we can see on the moon's exposed surface. The Maria is speculated to be remainders of vast magma oceans which followed violent eruptions. Over the years, different theories have been put forward to explain the surface disparities between the moon's near and far sides. One of these theories held Earth responsible for this. As per this theory, Earth acts as a shield for meteor showers, allowing far less of them to reach the near side of the moon. However, this theory has now been disproved. Instead, the current explanation between the different looking faces relies on the fact that the far side is much colder and thicker. Therefore, the thinner crust on the near side has allowed many more magma eruptions, causing the lava to fill some of the larger craters. This eventually helped in smoothing the exposed surface to create the aforementioned darker Maria. We know the near side because we can see it, but how do we know what lies on the other side? Honestly, we didn't know anything about it until the first photograph of the far side was sent by the Soviet space probe Luna 3 in 1959. The images flaunted imposing craters and played a fundamental role in producing the first ever map of the moon's far side. Then, in 1968, Apollo 8 orbited the moon before returning to Earth, giving humans the chance to experience the far side of the moon. Up until 2019, we had seen and thoroughly studied the far side, but had never landed on it. All previous missions to the moon had landed on the near side, only because of communication issues. But the Chinese Space Administration found a way around this problem. They launched a relay satellite, QKO, which orbited the Earth, providing a link for communication between us and the far-off lunar surface. Eventually, on 3rd January 2019, the Chang'e 4 probe of the Chinese Space Administration landed its Yutu-2 lunar rover on the far side, more specifically, the Von Karman crater. Although the probe aimed to study the soil composition and temperatures, it unexpectedly discovered that the unexplored side was much colder than previously thought. Coming back to the Apollo 10 incident, the unsettling noise stopped after the astronauts emerged from the moon's far side. These noises remained a mystery for decades until another spacecraft recorded something similar in the outer solar system. The Cassini space probe picked up similar broadcasts from Saturn, but they have a scientific explanation. They were caused by charged particles moving through Saturn's magnetic environment. However, the unusual noises on the far side of the moon could not be caused by a similar phenomenon. That's because the moon does not have an atmosphere or magnetic field. So, since the noise cannot be from the moon, NASA's radio technicians came up with their own theory. They pointed out that it was due to some sort of radio interference. However, the Apollo astronauts did not buy the explanation. They never opened up about it publicly, and the source of these noises remains a mystery. The far side of the moon holds a plethora of secrets hidden beneath it. It also offers a prime location for radio telescopes to avoid any interference from Earth, helping humanity decode even those weak radio signals from deep space that otherwise get lost from Earth's radio interference. Several future missions are being planned to explore and utilize this dark side.